Hey, MathKook here. This video contains one of many examples in my Algebra 2 library. The rest of those examples, along with hundreds of other videos, are only available at MathKook.com. Let's MathKook it up. This question says, using the Rational Zero Theorem, find all possible rational zeros of the function g of x equals 3x to the fourth plus 10x squared minus 5. So what is the Rational Zero Theorem? Here it is. So if you're given a polynomial in this form, f of x equals ax to the n plus blah, 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 all the way down to your constant b. So a is your leading coefficient. So a is the coefficient in front of the term that has the highest exponent of x. And b is your constant at the very end. So the possible rational zeros are x equals plus or minus, and then all the factors of b, so the constant at the end, over all the factors of a, the leading coefficient, and all its possible combinations. So there's going to be oftentimes a lot of combinations for a polynomial. So in this case, let's go ahead and bring down our function g of x here and find out what a and b are. So a is, remember, it's the leading coefficient, and b is the constant at the end. So this one's pretty easy to identify. A is just 3, and b is going to be this constant at the end here, which is just 5. And we can take the absolute value of it. We do not need the negative. We just care about the absolute value of each of these constants. All right, so now we can find our possible rational roots. So possible rational roots. So it's going to equal plus or minus. And on top is going to be the factors of b. So in this case, b is 5. So all the factors of 5 over all the factors of a, which is the leading coefficient, which we identified as 3. And just as a reminder, we know 3 is the leading coefficient because this term here has the x to the highest exponent, which in this case is 4. So that's why a is going to be 3. Now this term could have been written in different order here, so always scope out the polynomial, look for the highest exponent of x, and then the coefficient in front of that x variable is going to be our a value, or the leading coefficient. All right, so we'll put that 3 here. All right, so our factors of 5 are just 1 and 5. And what are factors of 3? Well, those are just 1 and 3. Okay, so now we have to do all our possible combinations. So I'm going to start with a 1 here and then do the combinations with each of these guys. So 1 over 1 is just 1. So that's an easy one, plus or minus 1. Next we have 5 over 1, which is just 5. And then next, now we're going to do the 3. So we're going to do the 5 and the 1 here over 3. We'll start with the 1. So we have 1 over 3, which is just 1/3. And then next we have 5 over 3, which is 5/3. All right, so here's a list of all of our possible rational roots for the function g of x here, and we used the Rational Zero Theorem to find these possible rational roots. Hey Kook, if you found this video helpful, hit that like button, subscribe, and drop a comment. For unlimited access to all of my Algebra 2 videos, visit MathKook.com. Thanks for watching.